Warm greetings to all. I am Dr. Meenakshi, Assistant Professor of Geography, Nirmala College for Women. In this video, we are going to discuss about the surface configuration of the ocean floor. Introduction. Like the continents, ocean water conceals a considerable variety of landscape very similar to its counterpart on the continents. There are mountains, basins, plateaus, ridges, canyons and trenches beneath the ocean water too. It is the land beneath the oceans which has waves, has complex and varied features similar to those seen on land. They are created by tectonic, volcanic, erosional and depositional process as well as their interactions all contribute to the formation of ocean relief. They are divided into four major subdivisions based on their presence as follows. In the continental margins, they are called as continental rise, continental slope, continental shelf. In the deep ocean basin, they are called as trenches, seamounts, abyssal plains, abyssal hills, and there are mid-oceanic ridges. These are the bottom relief which are present in the ocean floor. And this image shows the various continental reliefs present in the bottom of the ocean floor. Based on their activity, based on their activeness, they can be classified as passive continental margin as well as active continental margin. In the passive continental margin, where there will be less tectonic activity, continental shelf, continental slope will be present. In the continental margins, which are very active, which has more plate movements, they have submarine canyons, continental rise, abyssal plains, oceanic trenches, and mid-oceanic ridges. Coming to the continental shelf, the first relief of the ocean floor, it is merely an extension of the continent. 7.5% of the total area of the ocean is occupied by the continental shelf, and it width varies from few kilometers to more than 100 kilometers. And continental shelves are the shallowest part of the ocean, having a gradient of 1 degree or even less. And they are covered with variable thicknesses of sediments brought down by rivers, glaciers, wind, from the land as well as distributed by the waves and currents. Moving from the continental shelf towards the other features, the load of deposits, the presence of sediments will considerably be reduced. This is the picture showing the presence of continental shelf in the ocean floor. It is a mere extension of the continents. These shelves are narrow where the high mountains are very close to and parallel to the coast, whereas the shelves are very broad when there is an absence of mountains. The significance of continental shelf, it encourages the growth of plankton, which is the food for fishes. It also the source of fish, minerals including sand and gravel. A large quantity of world's petroleum and natural gas is obtained from these shelves. Example is Bombay High and discovery of petroleum in the Godavari Basin are examples of onshore drilling on the continental shelf. Coral reefs and lipoclastic materials are also common on the continental shelf. Moving on to the continental slope, which is an slopy region of the continental shelf. There is an abrupt change of the gradient in the continental shelf, which is called as continental slope. It connects the continental shelf and the continental basin. The slope is 2.5 degree to more than 2.5 degree. It extends between the depth of 180 to 3,600 meters. The steep gradient of the continental slopes does not allow any marine deposits. It indicates the end of continents. Submarine canyons and trenches are significant relief features in this region, generally traversing to the continental shelves and coast. Next is continental rise. Along the base of the continental slope is the deposit of sediments. This belt of sedimentary deposits from the continental rise. When the slope reaches a level between 0.5 degree to 1 degree, it is referred to as continental rise. With increasing depth, the rise becomes virtually flat and merges with the abyssal plain. In some regions, the rise is very narrow, but in others, it may extend up to 600 kilometers in width. It is underlined by sediments of 100 meters thick. Coming to the submarine canyons, one of the striking features of the continental shelf is the presence of submarine canyons which extend to the continental slopes. These are steep-sided valleys cut into the rocks and sediments of the shelf and slope. They are very similar to the gorges found on the continents. One of the reasons for the formation of submarine canyons is the underwater landslide. This is an image showing the submarine canyons on the continental slope. They demonstrate erosion across all substrates from unlithified sediment to the crystalline rocks. Canyons on active margins are steeper, shorter, more dendritic, and more closely spaced than canyons and continental margins. It may range from altitude may range from 600 meter to 3000 meters. The sediments collected on the continental shelf get dislodged by the storm or earthquake. The force of these moving sediments erode the slopes as they come down, and a result of submarine canyons are carved out. The continental shelf is generally considered to be territorial water extents of the nations to which it adjoins. Submarine canyons are found opposite of the river mouth. Godavari Canyon in front of the Godavari Basin is 502 meters deep. The wall of the canyon is steep or vertical and made up of soft shale rocks to granites. Absence of sediments, average slope is 1.7 degree. A large number of canyons has been discovered recently. This is an image where we can see canyons, and the deposits which are moving along the canyons, which are eroded in the canyons, will be formed in a fan-shaped manner. The continental shelf usually ends at a point of increasing slope called the shelf break. The sea floor below the shelf break is called as continental slope. Below the slope is a continental rise which merges into the deep ocean floor called as abyssal plain, where the slope slowly merges into the plain region. Deep sea plains, they are otherwise called as abyssal plains, which occupies 2/3 of the ocean floor, extend from deep sea fans to trenches, flattest, smoothest, and least explored regions of the world, and because of the heterogeneous deposit present here and shallow water sediments that buries the irregular topography. Nearly 40% of the ocean floor depths is occupied by the abyssal plain. Depths varies between 3,000 to 6,000 meters. The plains are covered with fine-grained sediments like clay and silt. 75% of the oceanic relief is deep sea plains. Its proportion in Pacific Ocean is 80.3%, while in Indian Ocean it is 80%, but in Atlantic Ocean it is only 54.9%. There you find no river sediments. Deep sea plains are characterized by pelagic deposits of plants, marine animals, and siliceous remains, but there is no presence of terraneous materials since the sediments of the river cannot reach here. They have extensive submarine plateaus, hills, guyouts, and seamounts, and the landforms are mainly produced by volcanic and tectonic processes. The floor of the abyssal plain is covered by sediments. The sediments which are formed from the remaining of living things called as oozes. So we cannot find any inorganic sediments because of the absence of river sediments. Oozes can be seen in those seas which favor an abundant growth of organisms. Another type of sediments is red clay, which is of volcanic origin or made up of tiny particles brought down by winds and rivers. Next is the oceanic deeps. They are of tectonic origin and are formed because of the convergence of oceanic and oceanic plate, as well as the convergence of oceanic and continental plates. They are found adjacent to the areas of volcanic and earthquake activity, and they lie along the fringes of the deep sea plain at the bases of continental slopes and along the island arcs. Oceanic deeps consist of two types. One is deeps, which are very deep but only found along the narrow belt, and the other one is the trenches, which are very long and extensive and found parallel to the coastal island. The trenches are very common in the Pacific Ocean and form an almost continuous ring along the western and eastern margin of the Pacific Ocean, where there is more oceanic and oceanic plate convergence and oceanic and continental plate convergence. As many as 57 deeps have been explored so far, of which 32 are in the Pacific Ocean, 19 in the Atlantic Ocean, and 6 in the Indian Ocean. These are some of the trenches, names of some of the trenches which are found in Pacific Ocean, Atlantic, as well as in the Indian Ocean. And last but not the least is one of the most important and wonderful feature of the ocean floor, which is, we'll call it as a mid-oceanic ridges. It is composed of two chains of mountain separated by a large depression and found along the divergent plate boundaries. The various mid-oceanic ridges of the world are connected and form a single global mid-oceanic ridge system which covers every ocean. They are in total 65,000 kilometers and covers almost 23% of the Earth's surface. Mid-oceanic ridges are the world's largest mountain ranges existing below the marine waters. These mountain ranges have peaks as high as 2,500 meters and some even reach above the ocean surfaces. The most prominent feature of a ridge is its steep-sided central valley called Rift Valley. These ridges are either broad like a plateau, gently sloping, or in the form of steep-sided narrow mountains. The oceanic ridge systems are of tectonic origin. They are tectonically active zones wherein a new magma is expected to emerge on the ocean floor regularly. Small earthquakes occur frequently in the crest of mid-oceanic ridges, and most active volcanic regions of the earth are mid-oceanic ridges. They have a steeper and more irregular topography as a result of low spreading rate. And the rate of ocean floor spreading result from this process is from 1 to 20 centimeter per year, depending upon the particular mid-oceanic ridge. Mid-oceanic ridge runs down the center of Atlantic Ocean, slowly spreading a rate of 2 to 5 centimeters per year and forming a rift valley that is about the depth and width of the Grand Canyon. In contrast, the East Pacific rise is spreading quickly at rates of 6 to 16 centimeters per year. Due to fast spreading rates, there is no rift valley in the Pacific, just a smooth volcanic summit with a crack along the crest that is much smaller than the Atlantic Rift Valley. This is an image showing the presence of mid-Atlantic ridges as well as various ridges along the ocean floor. The mid-Atlantic ridge in particular is the longest one, which runs for about 40,000 miles long, encircling the whole world, which is about 2,000 kilometers wide. It is located between eastern and western margin of the Atlantic Ocean. It is in an elongated S shape in the general north and south direction and follows a sinuous course roughly parallel to the present coastal line. This is an image showing mid-oceanic ridges in the Iceland across the globe. Guyouts are flat-topped seamounts. It is also formed from the inactive volcanoes. It is a truncated seafloor volcano occurring as a flat-topped mountain which does not reach the Earth's surface. Guyouts are thought to be associated with the hot spots. If the flat top is created due to wave action, they are named after Swiss-American geographer and geologist Arnold Henry Guyouts. They are most commonly found in the Pacific Ocean. Their flatness is due to erosion by waves, winds, and atmospheric processes. The steepness of the most guyouts is about 20. Thank you for your patient listening.